Okay, we're looking at Chapter 7 review. We're going to be doing 7.1 to 7.3 in this video. Solve each proportion. So when I do this, I've got 2 times 15 and 3 times x. So I'm going to have 3x equal 30. So x will be 10 after I divide. In problem 2, I'm doing the same thing. Cross multiply, okay? And I've got 4x is going to be equal to 9 times, well, I got 9 times 16, but let's do it this way, 9 times 16. I could multiply that out and come up with 144, but if I divide by 4 here, I know 4 goes into 16 4 times, and x is equal to 36, me working without a calculator. In problem 3, cross multiply again, I got 12x is equal to 24. Divide by 12 and x is 2. Moving on to problem 4, I start working with binomials. And this cross multiplication, 3 times 7 is 21, but x plus 2 times 2 becomes x plus 2 is equal to 21. This is 2x plus 4 is equal to 21. I subtract 4 from both sides, and I get 2x is equal to 17, and I get x is equal to 8.5 when I'm done with that. And I'm going to shrink that down, bring that up so you can still see it, and work a similar problem over here in 5. So I got 4 times 9, which is 36. And I have 5 times x minus 3. So I've got 36 is equal to 5x minus 15. I add 15 to both sides. When I'm adding 15 to both sides, I get 51 is equal to 5x. Dividing by 5 is going to give me 10.2 is equal to x. Okay, we're going to group these together. Well, let's undo that. That's not going to help anybody, is it? Okay, let's group these together and shrink it down, and let's get to our last one. Now, here I'm looking at 12x, or 12 times 2x minus 5. And that is equal to 4x, not 12x. But now I distribute the 12, and I got 24x minus 60 is equal to 4x. I subtract 24x, and I get negative 60 is equal to negative 20x. And I divide by negative 20, and I get 3 is equal to x when I finish out this top section. And again, we'll get this all grouped together and shrink it down. Now, in this next problem, problem 7, the measures of 2 complementary angles are in a ratio of 7 to 11. Complementary angles are angles that add to 90 degrees. And this extended ratio could be written like this. And now I'm going, oh, complementary angles. So I've got 7x plus 11x is equal to 90. And now I've got 18x is equal to 90. And I divide by 18. And I'm going to find that x is 5. What is the measure of the smaller of the two angles? Now, x is 5. The smaller of the two would be 35 degrees because the larger one's 55 degrees. They both add to 90, but the smaller angle is 35 degrees. Okay, so that's my answer for this. Now, in 8, Jaden and Isabel share a reward of $40. In a ratio of 2 to 3. And again, this is an extended ratio, so 2x to 3x. How much does Jaden get? Now, Jaden was first, so Jaden was 2x, okay? And Isabel was second, so she's 3x. But 2x plus 3x is 2x plus 3x is equal to 40. That's 5x is equal to 40, and x is 8. So I plop that in, so Jaden gets $16. And Isabel, well, they want, and Isabella gets $24. And it should add up to 40 when I'm done. Now, looking at these next problems, in problem 9, and this is from section 7.2. In problem 9, the polygons are similar. Write the scale factor. Find the values of the variables. Scale factor is written with two good numbers. Okay, so right now I'm looking at 12 to 4. So my scale factor is 12 to 4 or 3 to 1. That's my scale factor. Okay, that's my first answer. They asked me to find the values of the variables. I've got y and I have z. And the best one to do in this first one is recognize I've got 12 to 4 and I've got y to 2. And I can set that up. And if I think about equivalent fractions, 4 and 2, what if I divide 4 by 2, I can get 2. If I divide by 12 by 2, I get 6. So y should be 6, but let's just double check. This is 24, 12 times 4, 2, excuse me, and then equals 4y, and 6 is equal to y. So y is 6 there. And now my last one, now I know y is 6. I know that's 6, and since y is 6, this is 18 minus 2, so 3 times 6 minus 2 is going to be 16 there. So now my next one, still I'm going to use 12 to 4 is equal to 16 to z. Okay, so I got 16 to z, 12 to 4, and I cross multiply. I get, and let's not even worry about cross multiplying. Let's reduce this one just to be different. This 12 to 4 can reduce to 3 to 1. Okay, so that comes out to be 3 to 1. So now I got 3z is equal to 16, and I divide, and I know z is equal to 16/3, or I could say z is equal to 5 1/3. When I'm done with that, just making sure that that's going to come out nice. So that's my z, it's 5 1/3. You can do whatever you want with it. When I'm looking at number 10, I'm talking about the fact that I've got an x and I've got a y, and these are going to be kind of tough to figure out. But if I'm really kind of thinking about Pythagorean theorem to help me out, this becomes an easier problem. First of all, my scale factor is 4.5 to 3, but 1.5 is in both of them. If I reduce that, that is the same as 3 to 2. So my scale factor is 3 to 2. Okay. Now I'm going to use that throughout, but I want to make sure you recognize that to get y, I am going to use Pythagorean theorem. A squared plus b squared equals c squared. And so I've got 3 squared plus y squared is equal to 7 squared. So I got 49 minus 9, so y squared is equal to 40. And now y is equal to 2 to the square root of 10, because remember 40 is the same as 4 times 10, and I'm going to take the square root of both sides. And so now I've got y is equal to 2 to the square root of 10 using Pythagorean theorem. So I know this is 2 to the square root of 10. And now that I do that, I'm going to switch colors, and I know my scale factor, which is big to little, 3 to 2. And I've got 5x in that one to 2 square root of 10. And now I've got 6. The square root of 10 by multiplying by 3 is equal to 10x. And I divide that 10. I divide by 10 there. And I'm able to find out that my x value, which is 6 to the square root of 10 divided by 10, is equal to x. And this is 3. This is 5, so it's 3 to the square root of 10 over 5 as my answer for x. Okay, and I can pop that in my calculator if I want to. I don't have one right here as I'm working, And so we can do it this way, and we'll get this group together and out of our way for this next one. And we'll do the same thing with this side. Okay. Now, if I'm looking at 11, they're telling me that these are similar. They told me at the beginning the polygons are similar. Well, fine stuff. Well, if they're similar, I know x is equal to 30 degrees. Okay, right off the bat, because they are the same angle. Now remember, in similarity, the angles are the same, the sides are proportional. Now, my scale factor is 8 to 5. I got 8 in that triangle, 5 in that one, 8 to 5. Now, I've got an 8 to 5 ratio, and that is the same as y to 2.5. So now I cross multiply and get this solved. So I got 5y is equal to 1620, and y is equal to 4. When I'm looking that over, and now I can take this one. I don't have any other variables in there. I'm going to shrinky dink this one down, group that up, and get that down so it's out of my way for the next problems. Now, in 12, this one's a little bit more involved because it's got a couple variables that I've got to deal with. In problem 12, we're looking at a scale factor. If I look at 7 and 3.5, okay, and I've got 7 is the 3.5, so my scale factor, first of all, is 7 to 3.5, but that reduces to 2 to 1. So I've got a 2 to 1 scale factor. I'm going to use that, by the way, to help me set up my problem. Now, I want to make sure you recognize a couple things here. We're going to be using a system of equations setup for this problem. This one's a little tougher, but not impossible. So I know I've got 2 to 1, and I'm going to set up my first relationship, which is x plus 4 to y. And I'm going to set up my second relationship because I still have 2 to 1, and I have 3y to x. Now, my 3y to x is 2x is equal to 3y. My other one is 2y is equal to x plus 4. And now I get to look at this and make a determination of how I want to solve for stuff. And if I subtract 4 from both sides, I got 2y minus 4 is equal to x. Now, where I see x here, I can plop in the 2y minus 4. So I have 2 times 2y minus 4 is equal to 3y. And now I just solve from there. So I got 4y minus 8 is equal to 3y. I got negative 8 is equal to negative y, and 8 is y. So I know 8 is y, okay? So I take my 8, that's y, and plug it back in up here. And now I got 16 minus 4 is x, and 12 is x. So I'm able to find those two values, and I can get the opportunity to move on. I can group this thing and shrinky dink it down and bring it up here so I'm ready to go off to my next problems. Now here in lesson 3, I start right away with looking at something called side splitter, okay? Or no, it's actually not even side splitter on this one. This is angle angle, or side angle side, or side side side. So I'm really looking at side angle side here because they're saying angle C is the same in both these triangles. I've got the small triangle, which is 12 to 21, and remember this becomes 20, and this becomes 35. That should be a 3. So now I've got 12 is to 20 as 21 is to 35. Now, can you prove the triangles are similar? And that's what we're doing. This should have a cross multiplication. 12 is 20 and 21 is 35. I can either cross multiply and have it be the same value or reduce and have them be the same value. This is 3 to 5 on this side and this is 3 to 5 on that side. So yes, they're similar, but remember I used the idea that angle C is the same in this triangle and angle C is the same in this triangle. And now I can use the side angle side. So they are similar. Because of side angle side similarity. Now in this next one, in 14, this one will be a little bit easier because this angle and this angle correspond. This angle and this angle correspond. And we learned something in first semester about third angle theorem. And if two angles of one triangle and two angles of the other triangle are congruent respectively to each other, the third angles in both triangles are congruent as well. So I know these are similar, yes, similar, by angle similarity. Okay, so triangle XZY is similar to triangle EWN. And I've got to go back here. I wrote a similarity statement. That's my similarity statement right there. Okay, and I forgot to write my similarity statement in my previous one, so I'm going to get that done now. So I've got triangle CPM is similar to triangle CTQ. All right, so let's go on to this next page. Now in 15, we're trying to figure out if they're similar by this previous instructions are there. And I've got 12 is the 24 and 15 is the 16. And the reason is this and this are they're not the larger. In this one, this is the I hate it when I started it that way. That shouldn't be 12 is the 24, and we're not even going there. Let's talk about it this way. I've often talked about the fact that the largest is going to be proportional to the largest and the smallest to the smallest. So let's go to small to small. Okay, because that's small and the two triangles, to 15 to 24. Now, I should be able to reduce these and have them be the same or have a cross multiplication that'll work out. Now, 12 times 24 is 144 times something, something, something. But let's see what I've got with the calculator here. So I got 12 times 24 is equal to 288. So I've got 288, 12 times 24. 16 times 15 is equal to 240. These are not equal, so triangles are not similar. Okay. Now in this next one, I'm looking at this, and they're asking if this triangle is similar to this triangle. And angle B is the same angle in both triangles. Angle D here corresponds to angle C there. And because of angle-angle similarity, I have the two triangles similar. So triangle ABC is similar to triangle EBD because of angle-angle similarity. In 17, I'm looking at side-side-side similarity because all the sides are the same. So I'm going to line them up from least to greatest in the first one and hope they line up least to greatest in the second one. And see what's going on. They actually reduce to 2/3. And because of that reduction, these are similar. Okay, triangle ZXY is similar to triangle QPR because of side-side-side similarity. And this next one in 8, I have 18, excuse me. I'm looking at an angle that's helping me out, and because of that angle and the size of the sides, 10 is the 6 and 4.8 is the 8. Now if I can reduce that and find the similarity, that would be great. And now I'm looking at that, and this is actually something that'll work, because if I'm talking about 5 to 3, okay, and this is going to be 0.6 to 8, 0.6 to 4, excuse me, and that's 0.6 to 40. Maybe this is not going to be similar. Let's see what we've got. And did I set that up? Ooh, nope, you know, I screwed that up. That should have been 8 on top, because the inside, so it should have been 8 on top, 4.8 on the bottom. And now I'm looking at this. If I move this decimal once, this is 80 to 48, and 8's in both of them. So I could go 10 to 6, and that would also be 5 to 3 as well. If I reduce that one down, that would equal 5 to 3. So they are similar by side similarity. Oh, excuse me, side angle side similarity. And with that, I've got triangle JHK is similar to triangle SRT. Refer to the figure at the right, explaining how you know that segment AB is parallel to segment ED. AB is parallel to ED. Now, if they are to be parallel, I have to have alternate interiors congruent. Okay, so to make that congruent, I have to show that the triangles are similar, and based on this connection. And 4 to 8 as well. And I'm looking at this as 1 to 2 all the way across. So these are similar triangles. By side similarity. And because they're similar, all the interior angles are the same. So because since all the interior angles are congruent, and I now have alternate interior angles congruent, and then by alternate interior angles converse, I have AB parallel to DE. Okay, my last one, you want to determine the height of your school building. The building casts a 6-foot shadow. Your building casts a 6-foot shadow. So that's 6-foot shadow. You don't know X. At the same time, you cast a 15-inch shadow. You cast a 15-inch shadow, 15 inches. And if you are 5 feet tall, how tall is the school building? So you go height to height, shadow to shadow, and I've got a 15 inches is 15/12 of a foot, so I've got shadow to 6. So now I'm looking at cross multiplying this. By the way, this is 1.25 feet. And now I cross multiply and find out that 30 is equal to 1.25x. And 24 is equal to X. So the building is 24 feet tall. Thanks, that's for 7.1 through 7.3. You'll get a second video for 7.4 and 7.5.